In this video, we're looking at section 2 on limits. And we're going to look at what happens as x approaches infinity, so end behavior sorts of ideas. And then eventually we'll also get into what happens as y approaches infinity, which is more of a vertical asymptote idea. So that's what the first paragraph here talks about. We're going to start with horizontal asymptotes. And we've looked at that throughout the year already, but basically we're going to look at what happens as x gets close to infinity, or as x gets close to negative infinity. Do the y values seem to be approaching a consistent number? So in this definition, b is that number that it's approaching. And then an important thing to note is that for rational functions, if you have it, let's say, approaching 2 on the right side, it's got to do the same thing on the left side. So if there happens to be a horizontal asymptote, it's the same on either end. And we've talked a little bit about how we know what that is already. I'm just going to quickly simplify that rule or clarify that rule again. We're going to be looking at two polynomials. M is the degree of the top polynomial, and n is the degree of the bottom polynomial. A is a coefficient, B is a coefficient. So we can look at three different things. We can look at when m and n are equal. We can look at when m is less than n, or when m is greater than n. So we're familiar with kind of what we do. We do take that largest degree and the coefficient in the numerator and in the denominator. So for all three cases, we're going to start with a times x to the m power divided by b times x to the n power. We're just going to kind of clarify what happens with each one of those. So if m and n are equal, that means that the x chunks are just going to cancel off. Let me see if my highlighter works here, but these two things are going to be exactly the same, so they just cancel off and we're just left with a over b. So that's going to be the model that we use. Again, we've done this before, but one way we could say that is as x gets close to infinity, what we're going to notice is that y is getting close to that idea of a over b. A is a number, b is a number, so that means that in the end we do have a horizontal asymptote, and that's going to be y equals a over b. Okay, if we were to look at that second case, that's where m is smaller than n, and when that happens, all the x's are going to end up in the denominator. So we would just have an a left in the numerator. We'll still have that b there, but then we're going to have something related to an x in the bottom. It's going to be whatever, because n is bigger, n minus m in the bottom. And we know that when there are x's left over in the bottom, in general, then we can say as x gets close to infinity, that means y is going to get close to 0. So again, that's a number. 0 is a number, so we do have a horizontal asymptote, and that's going to be as y gets close to 0. Okay, and then our last case, when m is bigger, so now the larger degree is in the numerator, we're going to be left with an a in the top, and now we're going to have x's in the top. It's going to be whatever, because m is bigger, it's going to be m minus n in the top there, and then just a b left over. And whenever we have x's left over in the numerator, we would say, well, as x gets close to infinity, y is going to approach some sort of infinity idea. We don't know if it's going to be positive or oops, don't know if it's going to be positive or negative. Let's see if I can undo that. There we go. Because that depends on the coefficients. It depends on what a and b are doing. So in that case, whenever we have that, then we'd say there's no horizontal asymptote there. So that's all kind of review. We've done that before, just trying to clarify what some of our rules are. If you have a different way of remembering that, that is totally fine. Jot down some questions. We will see you in class.